lesson is on evaluating logarithms. In short, a logarithm, or you will see the word log, is the inverse or opposite of an exponential function. So when you're working with logarithms, you want to think in terms of exponents. Essentially, some number to what power equals some other number. So the left-hand side here, I have log form. The right-hand side, I have exponential form. So you might have log base b, where b could be a number, of some number y, where y would also be a number. You're going to think b to what power, or x, which is what you have to think about or solve for, equals the other number y. So I'm going to go through about 11 examples with you. Logarithms are related to exponents, so that's how we'll be doing the lesson today. If you were wondering how logs could be used, they could be used for graphing purposes. If you don't want a linear scale, you might do a logarithmic scale, which would show percent change or multiplying by a certain factor. Also, it would avoid any strong skews or outliers in your data by making a better graph of that. But for today's lesson, we're going to evaluate logarithms. Okay, so we're going to look at the examples on the screen, apply the definition of a log to exponential form, and then solve them. So first example, log base 7 of 343. Okay, so what this means would be 7 to some power, you could call that x, is equal to 343. Okay, so you would either do mental math or use a chart of powers or a calculator. So I know 7 squared is 49. So let's try 7 to the third power, which would be 343. So that implies x is equal to 3. All right. So because 7 to the third power is equal to 343, so your answer would literally be 3. Okay. For example 2, log base 3 of 81, that means 3 to some power x is equal to 81. You could use a calculator or mental math. The answer would be 4, because 3 times 3 times 3 times 3 would be 81, or essentially 3 to the fourth is 81. All right. So the rest goes pretty quickly. Log base 2 of 16 would imply 2 to some power equals 16. 2 squared is 4, 2 to the third is 8. 2 to the fourth would be 16, so that's also 4. Example 4 is a little different. Our value of y is a fraction, so this would be considered 4 to some power x is equal to 1 over 16. So we need a negative exponent. Remember, for negative exponents in math, you flip the base. So x would be negative 2, simply because 4 to the negative 2 flips to 1 over 4 squared. Again, when you're flipping the base, the exponent becomes positive, which is 1/16. All right. Log base 5 of 1/5 would be 5 to what power is equal to 1/5. That would imply x equals -1. All right. So you should be getting the hang of this. Now, example 6 is a little different. What if the base or subscript is not written? Okay. Log is understood to be base 10. That's what it means. So if it's not written, it's base 10. So 10 to what power is equal to 1,000? So that implies x equals 3, because 10 cubed is 1,000. 7, 4 to what power is equal to 1? Okay, so to get 1, you need a 0 power. So remember, anything to 0 power is equal to 1. Okay. Example 8, you might see the ln button on your calculator. It's called natural log. What the natural log is, it's base e. E is from a mathematician named Euler or Euler, some people call it. It's spelled E-U-L-E-R. So this problem would be written as e to some power x is equal to 1. So that also implies x would equal 0. Example 9 has a square root. So we're going to consider this as log base e of e to the 1/2 power. Remember, square root means 1/2 power. I'll indicate that in pink or magenta. Okay. So then that means e to what power is equal to 1/2. Sorry, I meant to say e to what power is equal to e to the 1/2. So that implies x would equal 1/2. Because we have the same base, it follows that x equals 1/2. All right. 10 and 11 are a little tricky. So we'll consider this as log base 2 of 16 to the 1/3 power. Okay, so that means 2 to some power is equal to 16 to the 1/3. All right, so we need the same base. Okay, so we have a 2 and a 16. You may realize that a common base would be 2. So I'll rewrite this also as a 2 to the x power. And then 16 I'll rewrite as 2 to the 4th. Then don't forget that little 1/3 we had. So this whole thing follows suit. 2 to the x is equal to 2 to the 4/3. All right. So that implies we have the same base, which, as I said before, it implies your exponents would be equal. Please watch my lesson on solving exponential equations using a common base if you want to go over that. So x would equal 4/3. Lastly, example 11 is pretty similar to example 10. So I'll do this down here. 25 to some power x is equal to 1/625. So again, you need the same base. So I recognize 25 and 5 are powers of 5. So I'll write this as 5 squared. So I'll put that in green. 5 squared. Don't forget this x from up top. And then 625, I'll just verify, would be 5 raised to the 4th power. Okay. To get the fraction, I need a negative exponent. So it'd be 5 to the negative 4th power. So then this follows suit that 2x is equal to -4 because we have the same base. So then divide by 2, x equals -2. All right. So that's the lesson on evaluating logarithms using the definition of a logarithm. Thank you. Hope you learned a lot from this tutorial.